Hey everybody, so here's a quick video on the Momentum Lab for the online lab. Get my camera down here, but I should have just started there. So for this lab, also going to share my screen. All right, this is a three-part lab. The first part, you're going to set up the ruler and wooden board, grooved wooden board like so. They kind of show you. They got their ruler propped up on a textbook with a couple post-its under it, and then their groove board. The ruler also has a groove in it, which is going to be extremely helpful for making sure our marble rolls straight down this little ramp here. So in part one, you'll start with 4 small marbles at the bottom of the ramp. Take another small marble, and before you roll it, predict how many marbles you think you're going to roll. So I'll predict 1. I think the last one will roll, and hopefully this marble just stops at the end and they all roll. That's my prediction. So you'll start at the 15-centimeter mark, let it roll, and two moved. So not 1, but 2, so not bad. My other marble now bounced off, but so in the data table, that was trial 1. You'll roll. We rolled 1 marble, 1 small marble down the incline, and we hit 4 small marbles. Predicted 1 marble and observed. I should wrote 2 here. And the observation was it was about the same speed. So for the rest of those trials, you'll just list what they have. So they give you the number of marbles to roll on the incline. So for the 2 marbles down the incline, take 2 small marbles, put them at the one closest to the bottom of the ramp at the 15-centimeter mark, and let them go. They're all 4 of them moved. And then you just go on down the list, make a prediction, roll the marble down, and state what happened. So not doing any calculations there, but that's part 1. So on part 2 for this, you'll need your little digital scale, the marbles, the ramps, and then a ruler or the measuring tape. You're going to first pick which ball you're going to roll down the ramp, weigh that with the scale, record that mass in the data table. Then you're going to get another small marble that you'll leave at the bottom of the ramp, weigh it, record its mass, put it at the bottom of the ramp. So that one's going to go at the bottom of the ramp. Now we're going to roll the marble down, let it hit. That marble is going to roll down. This marble will also roll with some speed, and then see if the conservation momentum holds. So to do that, we're going to have to do it in 3 different parts. So this is where this one gets slightly confusing. So first part, we'll roll down our first marble, our marble 1, down the ramp. And when it gets to the bottom of the ramp, start a stopwatch and time it until it gets all the way to the end of the ramp. Now, we're also supposed to mark this board at 15 centimeters and 25 centimeters, and my tape fell off already. But just mark this with Sharpie. But so there's that. So you'll time the first one, how long it takes to go from the bottom of the ramp to the end of the ramp. I'll have to move this out a little bit because I'm going to hit this stuff. And then you put the other ball in the bottom, marble in the bottom. Roll the ramp ball down. When it hits, start the timer, and then time how long it takes this ball to get to the end of the ramp. So you'll record that time. And then the third part, you'll roll the ball down from the same 15-centimeter mark again. And when it gets to the bottom, start your timer. This ball will go to the end. Don't worry about it, but but then stop your timer when it gets to the 15 centimeter mark or the 25 centimeter mark if it gets that far. So each trial will be 3 parts. You'll first roll this, start your timer, stop your timer, get that time. We'll also know the distance of this board, which we can measure. So mine is about 35.5 centimeters or so. But then put your other marble, start at the 15 centimeter mark, roll it, start it, stop it. That'll give you the time marble 2 takes to get to the end of the ramp. And then the third part, do it again, but start and stop when marble 1 gets to the bottom. Start, stop. Try to get to the 15 centimeter mark there. So that's how you'll get the time for each of the marbles. So marble 1's initial time, that'd be 0.61 for this example. Then the time it took for marble 2 to get to the end of the ramp, 1.12 in this example, and then the time it took marble 1 once it hit marble 2 to get to the 15 or the 25 centimeter mark. So this one was timed to the 15 centimeter mark, took 1.07 seconds. And then you'll do that 5 times. So that'll give you an average time, and then with the time and the distance it took to get, or distance it traveled, you can get a velocity. So then you'll have a velocity for the initial velocity for marble 1, and then the final velocity for marble 2 and marble 1. And then you can calculate the momentum of each, because at the very beginning, got the mass of the marbles with the little scale. And you can calculate momentum. And then you'll fill this table out. So for part 2, you'll use a medium ball as marble 2. And part 3, you'll use a medium ball as the ball rolling down the ramp. And then on the third part, they haven't sampled any data. You'll use a large ball at the bottom, and then a small ball at the bottom with a large ball at the top. So a bunch of different variations. But once you got the momentum, you come to data table 3, and you can calculate initial momentum. So from setup A, initial momentum, which would just be the marble 1 initial, because it was the only one that had initial momentum. So 0.002, that would go there. And then the total momentum after would be the sum of these two. So the 0013 and 00061. So it comes out to 0.00191. So that's where that comes. And then you can count a percentage of momentum loss using that formula there. So difference of initial and final over initial times 100% will give you this percentage loss. So this number will be what you'll write your lab report about. And if it's under, we can say 10%, you can say it's valid, because some of these marbles, this one is almost shaped like an egg. So these aren't the best crafted marbles. So this experiment can have some issues. Then after that, using graphing software, generate a graph total momentum before and after. So just a little idea what that looks like. It should be very close to a straight line with a slope very close to 1. So in a perfect world, if your initial momentum and final momentum were the same, this would be y equals 1x. So then there's the third part. The third exercise is just a simulation. So I won't spend any time rambling about that. Get this out the way. But you use little curling stones to bump into each other. So that's it. I guess I can change this there. But so that'll be it for the Momentum Lab. If you got any questions, just send me an email. Thanks.